Hello and welcome back for another VMK in the C++ series. In this VMK I'm going to describe the differences between classes and structures. Both of these are used in the exact same way, and there's only one real major difference between a class and a structure. So let's go into C++ and I'll demonstrate the difference here. We'll go in and create a new project. It's going to be Win32 console project, and I'll call this guy classes. Under application settings, we're going to have console application selected, and this will create our main entry point into our program. Just to start off nice and neatly here, we're just going to print out to the screen some carriage returns like so. Now, you've already seen me do this before in a different VMK where we can define a struct by giving it a name such as enemy. And then inside of the structure, we specify all the variables that we want to group together. So for instance, maybe we have something called beAlive, and maybe another one which would be an integer containing how many ammo this enemy has. Don't forget to have your semicolon at the end of the definition of the structure. Then inside of your code, you can create a new kind of enemy just by going enemy and giving it a name. So this variable, maybe it's called Dr. Evil. And Dr. Evil will by default have beAlive equal to true, so Dr. Evil will always be alive. And Dr. Evil will have some ammo, so let's give him 10 bullets. If we were to go and compile this program, we see that it fails. Wow, that was surprising. Oh, I forgot to disable precompiled headers when I defined this project. So we can go ahead and do that just by going under C++, precompiled headers here, and select not using precompiled headers. Okay, let's compile this, and now it succeeds because we're no longer using precompiled headers. And underneath our class view here, we can see we have our enemy structure, and inside of our main we have, well, inside of global functions we have our main. So everything is fine. Now, if we were to take this structure and convert it to a class, we can do this. Now our enemy is not a structure, it's a class. And you notice that over here, what happened was our member variables got this little lock symbol appearing beside of the variables. Let me change this back to struct to show you exactly what happened. I change it back to struct, this icon here changes, and those locks disappear. If I change this to a class, it behaves exactly the same way, but this icon changes to be a class definition, and we get these little lock icons appearing. Now if we try to build our program, or compile it at least, we get errors. We cannot compile this program because we have an error message that says, beAlive cannot access private members declared in class enemy. The same thing goes for IAmmo. Because we have these little lock icons, this tells us that these variables are private. So we cannot access these variables the way we're accessing them over here. By definition, structures have all of their member variables and functions, for that matter, to be public, whereas classes, by definition, have all of their member functions and variables to be private. So just by changing this one word here from struct to class, we've effectively made these guys here private. That's the only difference between classes and structures. Beyond that, you can go in and make a class behave just the exact same way that a structure behaves, and vice versa. So, if you are using a class that has private members, what do? You can't access them this way. Instead, you have to declare these variables to be public, or you have to declare some member functions of this class to be able to access these variables internally. So let me show you how to do this. We're going to get rid of this class, and I'm going to show you how it is that I define classes inside C++. Anytime I create a new class, I always break it up into public and private, and then I have a divider in the middle, and then public and private a second time. The guys at the top are going to be containing my functions. The guys at the bottom are going to be containing my variables. Anything that I declare in here will be a public function. Private functions will go down here. and then public variables will go down here, and private variables will go in here. So if I was to create a new class called monster, maybe this monster here will have two member variables. One which will tell us whether this monster is alive or not, and another variable which will tell us whether the monster is scared or not. I'll make one of them public and the other one private. So under the public section for the variables, I'm going to define a boolean, and we'll call this m_be alive. And in here, I'm going to make another boolean, m_be scared. Let's get rid of this stuff here as well. So if we take a look at the class view here, we see we have the little lock icon beside be scared because it is private, and the public one, he doesn't have a little lock icon, so everything's okay. Now I can create a variable, a monster variable. Let's call him, I don't know, the blob. And if I go like this, blob.mBalive is equal to true, and I go and compile this, everything is fine. Because I have access to this variable because it is public. However, if I try to do the same thing with mBScared, like so, it won't let me compile. And this is the same problem we had before because we're trying to access a private member that is not public. But I do not have access to it. So because bScared is under the private section, we have to handle this a different way. Anytime that I'm working with classes, I like to name all of my member variables with an M and an underscore at the very beginning so that it is clear to me that these variables belong to this class. And this is very helpful whenever you start creating large programs because you'll have functions that will be accessing many different variables at once. And you want to keep track of which ones belong to the class and which ones are parameters that you're using just inside of a function or that you're passing into a function. So let's go into this monster class. Whenever we create a brand new monster, like so, we're going to create a monster by calling the monster constructor. Now, there is no monster constructor defined here, so C++ is by default not going to do anything for us. But if I define a monster function, this function has to be the same name as the class name, then by doing this, we will cause C++ to automatically go into this function anytime we create a new variable that is of this type. So in here, we can define how we want our variables to be set. So for instance, we want to have beAlive to be true, and maybe we want to be not scared, so we're going to take this variable and set them equal to false. And down here, what we're going to do is just print some stuff to the screen. So we'll go printf, monster is %s and %s, comma, and then here we're going to have blob m_beAlive. Actually, I need to pass this into here. So if he's alive, we're going to display alive. Otherwise, we're going to display dead. And then for the second parameter, well, actually, right now we can't display him because we have no means to do that. So I'm just going to leave this guy blank for now. And then down here, we're going to go blob.mBalive is equal to false. And we're going to redisplay that string of text to the screen. Okay, Control F5, run our program, and we see at the very beginning the monster is alive, then we've toggled it to be false, so then the monster is dead. So by default, whenever we created our program, our monster was set to be alive because in our member variables here, we set them to be true. If we want to have access to this m_beScared variable, we need to create a public function that we can access. So we can do something like this. Return to us a Boolean value, and this Boolean value will tell us if the monster is scared. And what we're going to be returning is m_beScared, like so. Now, inside of here, we can go %s, and %s. And again, here we can go blob dot call this function is scared, and depending on what this guy returns, we're going to display something different to the screen. So if he is scared, we're going to display is scared. Otherwise, we'll display is fearless. And I might as well just copy this and paste it down here. Save myself some typing. So there we go. We have monster is alive and is fearless, and then monster is dead and is fearless. I have a couple extra spaces here because I put these extra spaces in here. Okay. So now we have a means of extracting this variable even though it's private. We do this with this public function. We also can create another function to actually set this variable from our program down here. So to demonstrate that, let's go and create a new function. It's not going to return anything, and we're just going to pass in here the name of the function, setScared, and we're going to have to pass in a variable that's going to tell us whether this guy is scared or not. We don't actually have to have the implementation of this function directly inside of the class definition. We can put it anywhere we like, and usually you do split these up into a header file and a CPP file. And the way we would do that is, let's say down here, we know we're belonging to a monster class, so we're going to have to use this monster keyword, and our function is going to return void, so we're going to specify here void monster double colon and set scared. Bool be scared, and then we write out our actual implementation here. So we want to manipulate this variable, so we're going to set this variable equal to whatever this variable is that that gets passed into the function. So now from our program blob.setScared, we can make him scared by setting this equal to true. And there we go. Monster is alive and is fearless, monster is dead and is scared. So that's the general idea of classes. If you have functions that are public, you can access them, but if you have functions that are private, you cannot. So for instance, I can also go in here and maybe make another function void kill monster. And automatically when I do this, we're going to set mb alive equal to false. However, there's no way that I can kill this monster from my program, because you'll notice over here, kill monster has a little lock icon beside it. And as soon as I try to kill him this way, and I try to compile my program, it brings up an error message saying that kill monster cannot access private member declaration in class. So this guy is private, I do not have access to him. I can only access this function from within another function inside of my class. If I want to have access to this function from externally, like so, then I'm going to have to make it public. So let's get rid of this guy. And the same thing goes with variables. If they're public, you can access them. If they're private, you cannot. But if they are private, you can still access them with any functions that you have inside of your own class. So there you go. That's a quick introduction to classes and the differences between classes and structures. They're pretty easy to use, and they can get very complicated because classes can be built one on top of another to give very complex structures. Using object-oriented techniques, you can encapsulate ideas inside of a class and just continue building and building upon these ideas to get very complicated things inside of your programs. But I didn't want to go into those in this VMK. I'm going to touch on those different subjects in a couple of future VMKs coming up.